The hydrosphere is a critical component of our planet, covering over 70% of the Earth's surface. It includes all the water on Earth, from oceans and rivers to glaciers and groundwater. But have you ever wondered about the chemistry of the hydrosphere? In this video, we'll explore the fascinating world of water chemistry and its role in shaping our planet. Charts of oceans, rivers, glaciers, and groundwater. Water is a unique substance with properties that make it essential for life as we know it. It's a polar molecule, meaning it has a positive and negative end, which allows it to form hydrogen bonds with other water molecules. These bonds give water its high surface tension, allowing it to stick together and form droplets. Those are shots of water droplets. Water is also an excellent solvent, meaning it can dissolve many substances, including salts, acids, and bases. This property allows water to transport nutrients and minerals throughout the hydrosphere, making it a vital resource for all living things. Shots of plants and animals in water. But water chemistry is not just about its physical properties. The hydrosphere is also affected by chemical reactions that occur within it. For example, the carbon cycle involves the exchange of carbon dioxide between the atmosphere, ocean, and land. This cycle plays a crucial role in regulating the Earth's climate. Shots of carbon dioxide being exchanged between the atmosphere, oceans, and land. In the next segment, we'll dive deeper into the chemistry of the hydrosphere and explore how it interacts with other parts of the Earth's system. The water cycle is a continuous process that involves the movement of water through the hydrosphere, atmosphere, and land. It's driven by the sun's energy, which causes water to evaporate from the surface of the Earth and rise into the atmosphere. Shots of water evaporating from the surface of the Earth and rising into the atmosphere. As water vapor rises, it cools and condenses into clouds. These clouds can then release their moisture as precipitation, which can fall as rain, snow, or hail. Shots of clouds forming and precipitation falling. Precipitation can then be stored in various forms, such as lakes, rivers, and glaciers, or it can infiltrate the ground and become groundwater. Shots of lakes, rivers, glaciers, and groundwater. The water cycle is a critical process for the hydrosphere, as it helps to distribute water and nutrients throughout the planet. It also plays a vital role in regulating the Earth's climate, as water vapor is a potent greenhouse gas. Shots of the Earth from space, highlighting the water cycle. However, human activities such as deforestation and urbanization can disrupt the water cycle, leading to issues such as droughts and floods. Understanding the chemistry of the water cycle is essential for managing our planet's water resources and mitigating the impacts of climate change. Shots of deforestation and urbanization, as well as droughts and floods. In the next segment, we'll explore the chemistry of seawater and its role in the hydrosphere. Seawater covers over 70% of the Earth's surface and plays a critical role in regulating the planet's climate and supporting marine life. But have you ever wondered about the chemistry of seawater? Shots of oceans and marine life. Seawater is a complex mixture of dissolved salts, gases, and organic compounds. The most abundant dissolved salt in seawater is sodium chloride, which gives seawater its characteristic salty taste. Shots of salt crystals and seawater. Seawater also contains other dissolved salts, such as magnesium, calcium, and potassium. These salts are essential for marine life, as they help to regulate the pH and ion balance of seawater. Shots of marine life, such as coral reefs and fish. Seawater chemistry is also affected by biological processes such as photosynthesis and respiration. Photosynthesis by marine plants and algae can remove carbon dioxide from seawater, while respiration by marine animals can release carbon dioxide back into the water. Shots of marine plants and animals. Seawater chemistry is also influenced by physical processes, such as temperature and pressure. For example, as seawater gets colder, it can hold more dissolved gases, such as oxygen and carbon dioxide. Shots of ocean currents and temperature changes. Understanding the chemistry of seawater is essential for managing our planet's marine resources and protecting marine life. In the next segment, we'll explore the chemistry of freshwater and its role in the hydrosphere. Shots of freshwater sources, such as rivers and lakes. Freshwater is a critical resource for life on Earth, providing drinking water, irrigation for crops, and habitat for aquatic plants and animals. But have you ever wondered about the chemistry of freshwater? Shots of freshwater sources, such as rivers and lakes. Freshwater is a complex mixture of dissolved gases, minerals, and organic compounds. It's also affected by human activities, such as pollution and climate change. Shots of pollution sources, such as factories and cars, and effects of climate change, such as droughts and floods. The chemistry of freshwater is influenced by factors such as pH, temperature, and dissolved oxygen. For example, freshwater with a low pH can be acidic and harmful to aquatic life, while high temperatures can reduce the amount of dissolved oxygen in the water. Shots of aquatic life and water quality testing. Freshwater chemistry is also affected by nutrient cycles, such as the nitrogen and phosphorus cycles. These cycles can be disrupted by human activities, such as fertilizer use and wastewater discharge, leading to issues such as algal blooms and eutrophication. Shots of fertilizer use and wastewater discharge, as well as algal blooms and eutrophication. Understanding the chemistry of freshwater is essential for managing our planet's water resources and protecting aquatic life. In the next segment, we'll explore the chemistry of groundwater and its role in the hydrosphere. Shots of groundwater sources, such as wells and aquifers. Groundwater is an essential resource for drinking water and irrigation, as well as supporting aquatic ecosystems. But have you ever wondered about the chemistry of groundwater? Shots of groundwater sources, such as wells and aquifers. Groundwater is a complex mixture of dissolved minerals, gases, and organic compounds. It's also affected by human activities, such as pollution and overuse. Shots of pollution sources, such as landfills and factories, and overuse of groundwater sources. The chemistry of groundwater is influenced by factors such as pH, temperature, and dissolved oxygen. For example, groundwater with a low pH can be acidic and harmful to aquatic life, while high temperatures can reduce the amount of dissolved oxygen in the water. Shots of groundwater testing and aquatic life. Groundwater chemistry is also affected by nutrient cycles, such as the nitrogen and phosphorus cycles. These cycles can be disrupted by human activities, such as fertilizer use and wastewater discharge, leading to issues such as contamination and depletion of groundwater resources. Shots of fertilizer use and wastewater discharge, as well as contaminated groundwater sources. Understanding the chemistry of groundwater is essential for managing our planet's water resources and protecting aquatic life. It's also important for managing the impacts of climate change, such as droughts and floods, which can affect groundwater recharge and availability. Shots of droughts and floods, as well as groundwater recharge. In conclusion, the chemistry of the hydrosphere is a complex and fascinating subject with important implications for our planet's water resources and ecosystems. By understanding the chemistry of water, we can better manage our planet's resources and protect the health of our environment. Shots of the hydrosphere and its various components.